Hello Year 11, this is a Waves required practical from the Waves module. This one is 21 and it's about infrared radiation. Heat as a wave, infrared. And it's about how it's absorbed or radiated by a surface depending on the nature of that surface. We'll come back to what that means in a minute. So the electromagnetic spectrum, as you should know, and if you don't, watch the song on YouTube, you know the song I mean, starts like this. It starts right, radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-rays and gamma rays. Now what this required practical is interested in is this one, infrared. Lower in frequency than visible light, longer in wavelength. But that doesn't mean that it isn't still a transverse wave. The higher intensity will have a shorter wavelength infrared, and the lower intensity will have a longer. So hotter means more tight infrared, and longer means a lower heat. The equipment we will be using for this required practical is this. It's called a Leslie cube. I don't know why, probably after Mr. Leslie or Mrs. Leslie, depending on which way you look at it. Leslie cube is essentially an empty box. And in the empty box we're putting a light bulb. Now, if you've ever touched a light bulb, especially an old-fashioned one, you'll know that that can hurt, and the reason why is because it gets hot. So what we're putting in there is we are going to heat up the inside of the cube. Now around the outside of the cube we've got different surfaces. This one is a shiny white surface. This one is a matte finish, like a rough matte finish. Around the other side we have a shiny black surface, and all the way around the other side we have a matte black surface. Matte, M-A-T-T, means rough, as if it won't reflect. The heat, the light bulb comes from the heat here, the heat source, and we're going to track the infrared coming off each surface by using the data logger here. The red line we're going to see is going to be the dull black, the matte black. Blue will be the shiny black. Green will be the dull white or the matte white, and the shiny white will be purple. Now at the minute they're roughly, they're roughly about the same. They're roughly about the same. They're all about 1 watts per metre squared. That doesn't matter. Just know more numbers, more infrared. Higher numbers, more infrared. Okay, so I'm now going to turn on the heater, and in a minute it's going to kick in. The heater is now on. We've got 9 volts going in, and it's been on a few seconds, and already we can see quite a significant difference. The red and the blue lines have started to go up, and the green and the purple lines have started to go up. But we can see the red and the blue are bunching together, and the green and the purple, and that's because the red and the blue are the black surfaces, and the white are the green and the purple. We've left it a few minutes then, and we can see certainly a big difference between the black surfaces and the white. So what's the difference between the two? Well, I said the red line here is the matte finish, not the shiny finish. The shiny black is the blue one, and then the white matte finish is green, and the shiny white finish is purple. So here we can see that the black certainly emits more than the white, but in both cases the matte finish emits more than the shiny finish. And I'm now going to turn off the heater, and almost instantly we start to see a cooling effect going on, which we'll catch up with in a minute. So we've left this out for a few minutes, and you can see that we've got this characteristic cooling curve where it cools a lot early on and then levels out. The red line, the matte black finish, actually crosses the shiny black line there, which means that the matte black is actually emitting far more infrared radiation and cooling at a faster rate. that surface is giving off so much infrared it's actually cooling quicker than the shiny. The white, again, they don't fall so fast, so matte black is the best emitter of infrared, and shiny white is the worst emitter of infrared. This graph proves that. Why is it then that the black matte finish is by far the best absorber and emitter of infrared? Let's talk about absorption to start with the colour white and black, or absence of colours if you're really that way inclined. White reflects, black absorbs. So if you were out on a sunny day, this is the visible light coming from the sun. This is the visible light on the white, on the black. But with the white, all those different wavelengths get reflected. All the colours of the rainbow there get reflected. Which is why you see white. White is all the colours combined. But with black, it gets sucked in, it gets stopped, it gets absorbed. And that energy has to go somewhere, and that energy turns into heat. So that is why white, and it's a good idea to wear white in the sun and not black in the sun. And wear your black blazer on a sunny day, you know about it, so you'll take it off and you've got your white shirt which reflects the heat. And the same happens for infrared. It's the same for visible light as infrared. Infrared is still light, it's just not visible, which is a bit of another thing to talk about. Now the surface, matte and shiny. Well, a matte finish, the reason why it doesn't shine, reflect light back at you, is because it almost is like a really craggy old cliff face. Right, so you've got all these edges like that. And the shiny surface is a very flat surface. Now, they're not the same length. They're the same length like that, but they're not really technically the same length at all, because if I held that, if this was a piece of string, and I held that and pulled it down, hopefully you can visualise that it's a far longer line. And this means that more infrared can escape the surface, because there's more escape points. So a matte finish has a far larger surface area, and that's why matte can give off more infrared, because you've only got so much space that can get out of a shiny. So, in summary, the perfect absorber and emitter of infrared is black, matte. Why black? Because it absorbs wavelengths of light. Why matte? Because it has a larger surface area. And if you remember that and the Leslie cube, I think you should be okay for that required practical. Just to finish off this video, I'd like to show what happens after about 15 minutes, probably about 12 minutes. You can see that actually now all the surfaces are now nearly back to room temperature and pretty much at the same temperature. As you can see that the black ones have got a far steeper gradient, so they've got a far steeper rate of change. That means they are emitting more. And the white ones have got a lower gradient.